Hello, ladies and gentlemen. Today we're going to talk about congruence and triangles, and specifically how to tell whether two triangles are congruent or are exactly the same. So we're going to talk a little bit about classifying triangles today, and then we're also going to talk about how to show that triangles are congruent. So first of all, an equilateral triangle, actually all three of these types of triangles, are triangles or ways to classify those triangles based on their side lengths. You know what an equilateral triangle is, right? That's a triangle with all sides congruent, and we can mark that with congruency markings on all three sides. It also has all angles 60 degrees. Since there's 180 in a triangle and we know all the angles are congruent, then they're all 60 degrees. An isosceles triangle is a triangle with two sides congruent. So we can draw ourselves an example of that, and maybe we can mark these two sides congruent. So two sides congruent. Also on an isosceles triangle, the base angles are congruent. The base angles are congruent. And if you're not sure about what angles are the base angles, they're the ones directly opposite of the sides that are congruent. So if you take those congruent sides and trace them back, they're opposite of the congruent sides. A congruent side will always exist in a pair with a congruent angle. If there's congruent sides, there will be congruent angles with those sides. All right, and so when we have a scalene triangle where we have no sides congruent, then we also have no angles congruent. So no sides are congruent, and also no angles are congruent on a scalene triangle. All right. The next three ways to name triangles are based on their angles. So an obtuse triangle is a triangle with one obtuse angle. So it's right there. One obtuse angle. Of course, we're never going to have a triangle with more than one obtuse angle, right? If we have a triangle with two obtuse angles, that's more than 180 degrees right there, and we know that can't happen. So it's one obtuse angle there. An acute triangle is the kind we probably normally draw when we're drawing a triangle. It just has three acute angles. And then finally, a right triangle. You probably know some things about right triangles already. They have a right angle in them. Only one, because if we had more than one right angle, we wouldn't have a triangle anymore. So one right angle in our triangles. Coming down here, we'll talk about what are congruent triangles and why are they important. So congruent triangles are two triangles with all the same side lengths and angle measures. So two triangles with all the same side lengths and angle measures. Those two triangles are the same in every conceivable way. And a lot of our work in geometry is focused towards showing whether two triangles are congruent. Can I look at two triangles and can I say that they are the same? Right, that's probably pretty important. It's important for a lot of areas, but one that comes to mind right away is construction. Can I look at these two roof braces and say that they're exactly the same? Right? Maybe I can't measure them right away. Maybe I have some other tools at my disposal. Or maybe I can measure them, but how do I know for sure that they're going to match up and be the same? So there are four ways to show that two triangles are congruent. There should be four here instead of three. And your paper probably has four on it. And the ways that you can tell are based on the idea that with a certain set of restrictions, you can only make one possible triangle. So for side postulate, all right, postulate just kind of means reason or theory. For the side postulate, the idea is if you have a triangle, and maybe this triangle has sides 3, 4, and 5 units long, then if I gave you three other sticks, a 3-inch, a 4-inch, and a 5-inch stick, you could only make the same triangle. You wouldn't be able to make a different triangle. It would have to be the same as the one that you got the first time. There's no way to rearrange those 3, 4, and 5 lengths to be different. So if we see two triangles and they are marked in a way that shows that they have 3 pairs of congruent sides, then we know for sure that those triangles are congruent. All right? So we can write it in words here. We don't need to write it in words all the time, but we can say if 2 triangles have 3 pairs of congruent sides, they must be congruent. All right? We have 3 other cases where we have restrictions that allow only one triangle to be made. All right, another one is angle, side, angle. So if I draw a pair of triangles here, and I mark them, they're supposed to look the same, and I mark them with an angle and an angle that's congruent, a side and a side that's congruent, and another angle and another angle that's congruent. Notice angle, side, angle means that the side that's congruent is included right between the angles, right? The side that's congruent is right between the congruent angles. Well, there's only one way to make that kind of triangle, so those must be congruent to the same triangle. Angle, angle, side. We've got our triangles. If we mark the angle, and then another angle, and then an excluded side, right? Angle, angle, side would imply that that side is not right in between the 2 angles. It's out here somewhere. There's only one way we can draw those triangles. So those are congruent triangles. We can also call this the side, angle, angle postulate. That's totally fine. It's the same thing. And then the last one here, which you probably have on your paper, is side, angle, side. That's another way that we can prove that 2 triangles are congruent. So we've got our triangles, and we say maybe this side is congruent to this side, this angle is congruent to this angle, and this side is congruent to this side. And with that set of restrictions, there's only one possible triangle, so we know that that's the triangle we're looking for. You might notice there's a couple of arrangements missing, okay? We cannot have angle, angle, angle congruence. That doesn't make any sense because this triangle and this triangle might have exactly the same angles, but they're clearly not the same triangle. They're not congruent. So angle, angle, angle doesn't work. And you might have already noticed the other one that doesn't work. There is no ass postulate, guys. And it's not because it's a swear word. It's because this arrangement, angle, side, side, can turn into multiple triangles. So if I have like, I don't know, a 4-inch piece and a 5-inch piece, and then I have an angle over here, and I know that it needs to be like a 30-degree angle, but it can go on forever. This is going to make multiple triangles. This is not going to work. So the only 4 that work are here on the left side of the paper. All right, so how do I use these? Well, I use these to write congruence statements. So I say, these 2 triangles are congruent, and I know it because of this statement. So in this case, I've got 2 triangles. They each have 3 marked pairs of congruent sides. Therefore, these 2 triangles are congruent by side, side, side. But you may have also noticed the other blank here. We need to name our congruent triangles. And this one already gives us, should be triangle DBC. So triangle DBC is congruent to triangle, and we have to specifically name this second triangle in a very particular way. We have to name the second triangle in a way in which each letter in the second triangle matches up with the same letter in the first triangle. So this one starts with D, and D is in between the 1 hash mark and the 3 hash mark side. So this triangle is going to start with X, because X is in between the 1 hash mark and the 3 hash mark side. Then we have B. B is in between the 1 and 2 hash marks. Over here, Z is in between the 1 and 2 hash marks. So Z is the next letter. And then Y. Right? It's very, very important that we write them in the correct order, because what congruency statements tell us is that every piece in the first triangle has a corresponding piece in the second triangle. I could say that C and Y are the same. So angle C and angle Y are congruent, and indeed they are. I could say that side length DB and side length XZ are the same. And I look at DB and it's got 1 hash mark, and I look at XZ and it's got 1 hash mark. So I have to have them in that order so that I can pick out pieces of this triangle and say that each of these pieces are also the same. All right, coming over here, this one's a little bit harder to see because I have triangle DBC, which is this one over here, and it overlaps. All right, we can have overlapping triangles, and we do have overlapping triangles often. So if I'm going to name these, I have triangle DBC. So it starts at the point, reaches way over to the other side, and then comes back. And if I'm going to make that same pattern over here, it's going to start at point A, it's going to reach way over to C, and then it's come back to B. So ACB is my triangle. And then I say, well, why? And this is a little hard to see because they're overlapping, right? So I could, if I wanted, bring it out here and redraw it. And I could say, well, it's got an angle marked, it's got a side marked here, and it's got this angle marked over there. So that has 2 angles and a side, and the side is not included between the 2 marked angles. It's outside of the 2 marked angles. So that means that this must be angle, angle, side congruence. All right. In the next one, we have triangle EBA, and we're going to mark it congruent to triangle. Start in the middle again, E, down C, up D. So those are my 2 congruent triangles. And why are they? Well, they're congruent by side, 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 since we have all the sides marked. But also, they're congruent by side, angle, side, because we have a side, angle, side marked. However, they're also congruent by angle, angle, side. So that's marked as well. And they're even congruent by angle, side, angle. So this triangle is congruent by all of the different congruency postulates. You don't need to write all of them. You don't need to write multiple if there are multiple. You just need to write one. Okay, so we would just need one of these. And then finally over here, we have a triangle DCE, and we have this other triangle, but we only have 1 marking. And that's going to make it really difficult to find a congruency postulate. So let's see if we have anything else that we can mark. And we do. We have a pair of vertical angles. And since we know that vertical angles are always congruent, then we're going to use that idea of vertical angles right there being congruent to show that these 2 angles and those triangles are congruent. However, now we have 1 side marked and 1 angle marked. But there's not another way for us to see any other congruent pieces. Maybe in the diagram it looks like this angle and this angle are the same. Maybe in the diagram it looks like this side and this side are the same. But we don't have a mathematical rule that can tell us for sure whether any of those are the same. So we actually don't have enough information to make a congruency statement. We would say in this case that they are not congruent. And that might be kind of confusing too, because you say, well, they might be congruent, so why would you write for sure that they're not congruent? Well, in math, we're going to keep the idea of the null or the not happening until we know for sure that something else happens. So if we don't know for sure that they're not congruent, then we have to say that they are not congruent. All right. We're going to shift gears and come down here and do some algebra. We're going to classify triangles using algebra. So I'm going to take a look at this first one, and it says the triangle has a perimeter of 62. Classify it based on its side lengths. Well, I've got the side lengths here. I'm going to make an equation. So x plus 3 plus 2x minus 5 equals 62, because I know what perimeter means. Then I'm going to combine like terms. 4x minus 2 equals 62. Add 2 to both sides. 4x equals 64. Divide both sides by 4. X equals 16. Well, now that I've got x equals 16, I can use it and plug it in to the other to the other 3 sides. So this is 16. This is 16 plus 3, or 19. And this one is 2 times 16, so 32 minus 5, which is 27. So now I can answer the question. The question says classify it based on its side lengths. Well, its side lengths are all different, and I know that a triangle with all different side lengths is called a scalene triangle. So this is going to be a scalene triangle. We can also go the other way with our thinking. So this one says, if the following triangle is equilateral. So this is asking us to assume that the following triangle is equilateral. So in that case, we're going to say, okay, if the following triangle is equilateral, then we can say that this side and this side are equal. So x plus 8 equals 15, which then tells us that x equals 7. And we can do the same thing for this other side. We can say 1/3 y minus 6 equals 15. Add 6 to both sides. 1/3 y equals 21. Multiply by 3. Y equals 63. And all of a sudden, we've got x and we've got y. All right. And this practice together problem, you can try it on your own. You don't need to. It's a little bit challenging. I'm going to tell you the answer so that if you look at it and do it on your own, you'll know what they are. So the answer for the measure of angle y is going to, or which should actually say the measure of angle A. Otherwise, this is kind of a problem that doesn't really matter. The measure of angle A is 28 degrees. Okay, so see if you can figure out why that works, and then go ahead and do the 1.5 worksheet. All right, have a great day, guys.